A very pleasant good morning. Uh, Myself Kumar Ronak from Section D. So my today's topic going to be alternating current prerequisite for today's generation. Let's move to our next slide. So firstly we are going to know what is an alternating current. In shortly we call it AC. AC is an electric current that periodically reverses its direction in contrast to direct current which only flows in a single direction which cannot change sporadically. AC electricity is created by an AC electric generator which determines the frequency. An AC waveform can be sinusoidal, square or sawtooth shaped. Some AC waveforms are irregular or complicated. Here in this diagram we can see DC current has single direction while alternating current has both the direction backward and forward. So now we are going to discuss what are the advantages of AC. A single greatest advantage of alternating current is AC can be transformed but DC current cannot be. It can be controlled by wide variety of components like resistors, capacitors and inductors. This allows high voltage of electrical power to be distributed in smaller wires and with lower amperage. So now we are going to know what are RMS values. Since we know values of voltage and current are always changing, we need some way of averaging out their effect. We use RMS values, that stands for root mean square values. The RMS values are the DC values which give the same average power output. So here are the formula of current and voltage RMS values. I RMS is equal to I naught upon root 2 and V RMS is equal to V naught upon root 2, where I naught and V naught are the peak current and voltage values respectively. What are the application of AC? Alternating current is mainly used in the industry of transportation and production of electricity. AC is also the more popular current when it comes to the powering electric motors, a device that converts electric energy into mechanical energy. AC plays major role in making RLC circuits. So now we are going to discuss about transformers. A transformer is a device that transfers electric energy from one alternating current circuit to one or more other circuits, either increasing, stepping up, or reducing, stepping down the voltage. It is one of the major applications of AC electricity. Transformers are employed for widely varying purposes. Example, to reduce the voltage of conventional power circuits, to operate low voltage devices such as doorbells and toy electric trains, and to raise the voltage from electric generators so that electric power can be transmitted over long distances. So let's move to our next slide. Here in this diagram you can see step down transformer and step up transformer. In our next slide we are going to see what are the differences between step down transformer and step up transformer. So let's move to our next slide. Here are the differences between step up and step down transformer. In step up transformer, when the voltage is raised on the output side, the transformer is going to said to be step up transformer. In step up transformer, the number of turns in secondary winding is always greater than the turns in the primary winding. While in step down transformer, high voltage and low current power is converted into a low voltage high current power, and the number of turns on secondary winding is always less than the primary winding in step down transformer. In this diagram you can see in step down transformer NP, number of turns in primary coil is greater than number of turns in secondary coil, while in step up transformer number of turns in primary coil is less than number of turns in secondary coil. So this is all about my today's topic. Thank you so much.